external issuer kind of has the same kind of issues. Thank you for whoever pressed record. I forgot about that. Cool. So what I would like to see is some kind of cert-manager specific policy, which is native and has the same experience across whatever issuer implementation you're using, regardless if it's internal or an external issuer. So there's this design document. I think today I want to go through the APIs, the kind of soundness of approach, whether kind of the approach makes sense, and whether we should kind of go through with this approach basically. So the summary, I go into a bit of motivation, but basically what I just mentioned, that today we didn't have a great kind of policy story, and we want to improve that. The goals, we want to create a first-class kind of policy over snippet requests. Snippet requests specifically, as the kind of user info fields are coming through, and we'll have that available. And I'll go into a bit more detail about that. And certificate requests being our pod in Kubernetes is our kind of like smallest atomic resource, which makes sense to kind of tie policy there. We want to make sure that the policy is extensible to the upstream CSR API if we decide to adopt that in any way. I want to have the policy to be pluggable so that if our base policy spec isn't good enough for a particular use case, I'm thinking if someone wanted to plug in their own custom OPA or whatever random code that they want to run against the policy, then they should be able to do. Right, this is the kind of like only allow requesting certificates on Tuesday kind of use case kind of thing. We want to then we also want to make the policy management similar to other Kubernetes resources, just to have that kind of consistent user experience, and reduce the kind of time it takes for cluster administrators to kind of get familiar with the resources. So I'm thinking similar experience to things like network policy and the pod security policy replacement, or that kind of idea. So it should behave similar to other Kubernetes resources, basically. The non-goals are applying policy to certificate resources. I know that's quite a broader discussion that we've talked a lot about in the past. I'm not saying it can't ever in the future, but I think today, but just this design, we don't want to focus on that. I don't think doing anything in this design will back us into a corner where we can't perhaps achieve that in the future. But indeed, there's like lots of open questions about whether we want to do that anyway. Then we also don't want to discuss how you would design an external policy engine in this document, but we kind of provide or design the tools that someone could go ahead and create one after this is implemented. So the proposal is to add these approval conditions to the certificate request. So I opened up a PR yesterday to include those conditions. And this is effectively adding this kind of approved condition, which is set by a certificate request controller. That certificate request controller today in that PR just does approval. All other certificate requests are then gated on that approval condition. So this approval controller will then actually implement the policy when it exists, rather than just approving everything. A note that, and I mentioned that in the PR, is that we should add a PR to all external issuers once 1.3 goes live, if this goes into 1.3, to just add that if statement basically to all the specific request control loops, just so you have that kind of consistent kind of policy behavior. And we should be very explicit, for example, in our example external issuer controller, and write it in the docs, put it in bold and everything, that they do need to check this the approval condition, so they have the same kind of policy behavior everywhere. So the proposal that I'm making, and this is the kind of main part of it, is to add this cluster resource certificate request policy. This API is a bit outdated, so I have this. Perhaps it might be even better to look at the code. Hopefully everyone can see that all right. So the idea is we'll have this cluster scope certificate request policy. This policy, this resource will be managed by cluster administrators, the PKI team, the security team, who want to define the policy which should be applied to, across the cluster, across the organization. And what I've done is effectively take out most, but not all, certificate fields that exist on the certificate resource. The reason for doing it is that users of cert-manager are quite familiar with these fields anyway. Therefore, it kind of improves the user experience. It's like kind of the thing that people would expect. And yeah, they're just good fields in general to kind of have a good general overview of like how certificates would look like, right? Hence why they're in our certificate spec. There are certain fields which don't exist here, but do exist on the certificate resource. And they are specific fields where we can't get that information by looking at just the CSR. So I'm thinking about the private key encoding, for example, as the certificate request resource is not concerned with how the kind of secret should look like, right? So that field doesn't exist, for example. That is a limitation, but I think, yeah, that might be a separate conversation to have. Maybe this is where external policy comes in or whatever. So the way this works is that you can see that everything is a pointer. Generally how it works is that everything is allow all unless it exists, right? So let's take the allowed common name, for example, as a kind of simple case. If allowed common name is nil, that means any common name can exist. If a common name is a pointer to a string that contains ABC, then common name can only include ABC. And we also implement wildcards in this. So if the allowed common name here is a pointer to a string that contains star.abc, then any certificate signing request that includes 123.abc, etc., would be approved, but ABC wouldn't just by itself. So yeah, it's this kind of policy is like a kind of an allow list effectively, rather than like a deny list. And that's kind of how it works. The slices here, this is matching on subsets. So if we have allowed DNS names that include a pointer to a slice of strings of 123 and ABC, it would accept all certificate requests that include no DNS names, DNS names that include ABC or 123 or ABC and 123, but not ABC 123 456. So the kind of slice string matching is done as like subsets. And all those kind of subsets also can include wildcards as well. So that's how the kind of semantics, I guess, of the kind of string matching work. Yeah. The next thing.
Would there be a use case for like and versus or on doing those things? Like like DNS names, for instance.
Can you not do that's just subsets though, right? No.
But like, is it just theoretically, like, I don't even know if this would be a use case, like being like you're allowed to do a.com or b.com. Or the other case would be if you have a.com, you must have b.com in there as well.
Yeah. So no, not with this approach. So this approach is like strictly or. So it's all ordered.
Do you think there would be a reason why someone might want that kind of and that higher order logic? Or I mean, I know this is supposed to be just a baseline kind of simple policy, but would that be an important feature, do you think?
So I think in terms of certificates themselves, if you think like what a certificate gives you is like identity, I guess, basically, is that you can request less than what your total scope is, but you shouldn't be able to request more, if that makes sense. So like being able to request for no DNS names and requesting for 123, like and your identity is DNS with 123, then that is probably fine that you can also request with an empty DNS, but it shouldn't be okay that you are 123 and you're requesting for ABC. Like you shouldn't be able to request more than what you are. But you could request less than what you are. Because in the practical sense, what a certificate does is, you're verifying your identity. If you want to give a client or server less identity than you are, then you're not losing any security.
You're not it's not harming security, but maybe like it feels very concocted, but I can kind of come up with a reason why, like developers keep forgetting to request, dot as well as the thing, so that breaks, redirections or something like that. And so, but I think it feels very concocted and trying to force too much into this baseline policy.
I think our answer to this, if we go with this, would be that just use the OPA external policy server. I think probably if we do go with this, we'd probably release an external OPA server with it. And we'd just be like, if you want that specific use case, then include OPA to make sure that the field exists with that.
So this is trying to be just the baseline simple use case solving one that gets shipped. But if you want to do more stuff, there are alternatives available for you to migrate to do your super complicated rules.
Absolutely. Yeah.
Is there an example of like a YAML file with, for example, the policy and a certificate request that would not be matched or something like that?
Sorry, that's probably a good thing to include here. I've included like a small one below here, where you can see here that like it's only allowing URIs with this. For example, I do have like a test locally that I was playing around with. So you can see here that can you see that? Okay. You can see here that the DNS names here on the certificate request, you have like 123 cert-manager and ABC. The policy reads ABC 123 star cert-manager. So this wouldn't pass because this would be fine because this 123 star matches with 1234, but the cert-manager doesn't match. So that's like an example of the DNS. The common name here, for example, won't match. So this won't match because the common name has a dash at the end, and this like doesn't. But if I remove the dash, then the common name would pass.
That's the dash at the end there. That makes it an invalid host name, doesn't it? Is there any validation on it being a valid host name?
Sure. Yeah. I mean, these are very contrived, I guess, kind of tests that I was doing. Yeah.
Okay.
But you're right. It would be a valid host name. The actual policy engine behind this isn't concerned with the validity of the field itself. That should be the concern of the kind of cert-manager admission webhook. By the point that the kind of all the input gets put into the policy, all of these things will be validated anyway. So it's not really a concern of the policy engine whether the kind of fields themselves are semantically correct to the kind of things that's backing them. Besides, when it gets to the policy engine as well, it's a CSR like PEM encoded X509 certificate signing request. So it's even validated more than that as well.
Looking ahead a little bit, would you imagine like extending this policy to be able to like take other inputs as well? So you could do like DNS name matches the service name that the requesting pod is, like that kind of attestation type stuff? Or is that going to be not in this base policy, maybe not in policy at all? What do you think?
That's strictly an external policy server. And that's one of the use cases down here.
Okay.
That if you wanted to do something complicated like verifying the identity matches the kind of contents of the certificate signing request, then that would be a concern of an external policy. And again, like doing this kind of like specific certificate validation and things like that, like we can ship with these, but I don't think they should be part
of trying to do all of that in this base allow policy.
Doesn't go against what you said at the beginning when the policy matches the like base certificate request. And if you're gonna add it to identity, then yeah, you need something else that can both can check where the certificate request came from, like who requested it.
Mhm.
Cool. So
the other thing, I don't know, tell me if I'm just jumping ahead too much and you want to go through the rest, but like I talked to Josh about this the other day, so it's been ticking away in my brain for the last few days. One of the cases that we talked about, Josh, was a use case of everybody must have a minimum key size of 1024, but if you are requesting example.com, you must have a minimum key size of 2048 because that's our main domain and we want that to be extra secure. And that's quite hard to do with what's here. And I wondered whether it would be good to add basically duplicate all the allow fields with like a match prefix or something like that. And then you could then this policy applies if it matches this, and then the allow tells you what you can do. And then you could have a policy that's like match DNS names example.com, and then allow minimum key size 2048. And that seems like a fairly, I haven't thought it all through, but it seems like a fairly straightforward extension that feels useful. But maybe there's a lot more semantics required to actually define that, and it makes it a lot more complicated.
My feeling is that for the actual use case itself, you should probably be able to describe that using two different policy resources mapped to different namespaces or identities, I think. Feeling.
Okay.
Oh yeah, you could go ahead. You could do that, like you said.
So
with two different policies, yes.
So the behavior, basically we'll have a set of these policy resources. The default behavior, if no policy exists, is that the approver controller will always approve certificate requests. This is to keep kind of backwards compatibility in what the behavior is today in cert-manager. As soon as a single policy resource, certificate request policy resource exists, it will then enforce policy on every certificate request that exists, regardless of whether one is bound to it or not. Because if you don't have a policy bound to you, then your certificate request will fail. This bounding is done through RBAC.
So I think just a suggestion of an extra thing to add in here is we should actually have a flag somewhere that turns off the allow all mode, just so you can't accident. If you change your allback policy so the approval controller can no longer read policy objects, when you listed them, you'd get an empty return, you'd allow all, and you'd bypass all your policy that you configured because you messed up some allback somewhere else. So I think we should add in, I think that's a nice way of doing it, but there should just be a way of saying, no, I absolutely want to enforce policy. Don't do anything without a policy allowing it as a extra layer on top of that.
Yeah, I agree with that. I think that's a good addition to make. I think in that specific case, to be fair, the approver would error on the list, and therefore the certificate request would be undefined approved, and therefore wouldn't be approved or denied. But yeah, you're right. I think it would be a nice addition to have that kind of not default, but an option to have that allow all default behavior turned off. Yeah, I agree. So the way that this kind of binding works that I've been talking about is through RBAC. So since this is a cluster scoped resource, we can bind using RBAC to specific namespaces or cluster scoped, and then we can bound it to identities. I kind of briefly mentioned this idea of dimensions here, how the kind of resource can be used via dimensions, and we have these two dimensions. So we have a namespace dimension and a user dimension. So we can apply this kind of namespace dimension based on role bindings and through role bindings and roles, and those could be applied to system authenticated to particular namespaces. And so that kind of covers the namespace dimension. And then we can also do the kind of user dimension where we can do cluster roles and cluster role bindings to specific users and groups. And then we can do also a mixture of both of those things. So these are the kind of two dimensions that we kind of get out of using this kind of RBAC approach. When the approver or controller what it will do when it receives the certificate request, assuming that policy is enabled and it's not on an allow all state, it's going to do a subject access review based on the user info fields that were present on that certificate request. So it's going to list all the policy resources in the cluster, and then it's going to test whether that user is bound to that request to that policy or not. So first it will check like whether it's bound in that specific namespace this certificate request exists, and then again at the cluster scope. And yeah, it just kind of does this kind of cluster access review lookup. And then once it's done this cluster access review lookup, that will return whether the policy is bound to that user or not for this certificate request. And then it will just like cycle through every single policy. As soon as one policy succeeds, then it approves the request and it kind of exits early. If no policy succeeds, then it will deny the specific request, and that will be the kind of certificate request final state. The third thing is if the policy errors when it tries to evaluate, and this is kind of more to do with the external policy stuff. So yeah, if it gets into an error state, then it gets put into this kind of like pending policy bucket where it's kind of that policy hasn't been kind of evaluated yet. So if we have two policy resources, let's say, that's bound to a certificate request, the first one it evaluates and it errors, then that kind of gets put to one side. It's say the second one is denied, then that means that we're not sure if this certificate request should be approved or not. So it will be kind of deferred and retried at a later time, basically, and it will just stick the certificate request in a pending state until a policy can kind of make it true. So yeah, it's important distinction here that only a single policy evaluation needs to be true for a certificate request to be approved. So it's one of many rather than all of them that need to be approved. So that's everything for the actual kind of base policy itself, and then we have this external policy part. So in the resource, we can basically define a list of strings, and these lists of strings refer to an external policy server resource, which is also cluster scoped. And this basically describes one of these kind of pluggable servers. Inside it includes an endpoint, so this is just a kind of host name, Kubernetes host name or whatever, which should be reachable by the kind of cert-manager controller, and as well as a CA bundle. More on that in a minute, but the CA bundle basically describes the kind of CA that the kind of external policy server is going to be serving with, so that it kind of trusts the connection, obviously. The way that the controller is going to speak to these external policy servers is through Grpc, through like one of a managed API that kind of we define, which is defined here. So our requests will include effectively everything inside this certificate request resource. So the kind of rip out the things that matter to us will include the kind of Kubernetes metadata, so names, namespaces, annotations, labels, all those things. The CSR itself, obviously, and then the other kind of fields which are relevant. The external policy server will then return a response, and there are 3 states that it can return. So it can be either approved, denied, or errored. It's approved, obviously it's approved, denied, it's denied, and it will cause the whole policy resource to kind of deny the request, or we can return an error state. And this is where the policy might be deferred to be retried at a later time. The CA bundle, we can reuse the CA injector to make these things a little bit easier. So this kind of does the thing where we can inject the CA bundle based on Kubernetes resources. So when I deploy my external policy server, along with that kind of spec, I can include a certificate resource, and then basically I can add an annotation to this external policy server resource to kind of inject from that certificate, and it will populate the kind of CA bundle at runtime. This will be managed through a controller, obviously. It will kind of do health checks against the external policy server, which will manage the kind of status of the of the resource, and then as the approver kind of goes to look at the external policy server, it can use this status to know whether it's in a kind of ready state or not, and do that whole kind of deferring kind of malarkey. In terms of the design itself, I think that's like a good overview of how things work. I've also included the case studies that we talked about in the past, and how using this solution we can do like fix these case studies, basically, or user stories. Yeah, I think I've been talking for quite some time. What do people think, I guess, about the design from like a bird's eye view? Do people have concerns with it? Should we throw it in a fire? What do people think?
I'm interested in the gRPC thing. I don't think the OPA server supports gRPC at the moment. It's just an HTTP API. Any particular reason for that? It just seems to me like, in terms of an external policy server, OPA or an OPA server instance is the most likely first candidate, and that seemed to be a mismatch as far as I could see. But maybe it does support it.
No, yeah, that's a good question. So the idea behind this is that we want some kind of consistent API between our external policy servers and the cert-manager controller. It just needs to be one API. And then when a person wants to implement an external policy server, they'll be implementing this basically shim to translate this kind of common API to whatever implementation of a specific thing they're doing. So I would expect in the OPA case is that you'd have a shim between basically a Go process, which serves this gRPC, accepts input, and then we'll just run the OPA validation against, once it's done its kind of mutation, or however it wants to do that. And then the OPA pod can mount in through a config map or whatever it is, its rules, to do the evaluation. That was my feeling behind doing that. The reason why to pick gRPC, it's modern, it's well known, it's well tested, it's well defined, it's quick, it's
extensible.
It's well, like anyone can import your proto definitions and write their own policy server without having to understand all the pitfalls of reading an API spec.
Precisely, yeah.
And the great thing about the approach that you mentioned, Josh, is that you could do that and you could then wrap it with some of your own logic as well. Yeah, so you pull down the protos, as I said, implement them, the interface, and then you can go do the OPA stuff, and you could wrap OPA, for instance, as well. For instance, if OPA didn't serve your purpose, right, you could use OPA to do most of what you wanted, perhaps complement it with something else. So yeah, it seems like a really good approach. And I think most of the extensions are going this way, right, with gRPC, from what I can make out.
Yeah, that's my feeling as well. Yeah.
One thing that I've been thinking about is with the wildcard syntax. It allows at the moment for example, something like example.start, which would be example followed by an ETLD. I don't know of any use case where you would want that, because nobody realistically could control every one of those domains. It seems more permissive than it needs to be. It could potentially be quite damaging if you say had examplestar.com, where someone could register any domain there quite easily and get through the filter. The actual implications of that in terms of security they're not clear to me at the moment, because they'd have to compromise your cluster, I suppose, to be able to do anything there. But would there be value in locking down that wildcard syntax to match, say, let's say Grpc or indeed TLS wildcards, where, say, star.example.com is permitted, which will match hello.example.com but won't match a.b.example.com? Is that valuable?
I think it's a good point. I don't know if I want to be in a position where we dictate how stuff should be used. And I think at some point the onus needs to be on the cluster operator to set up these policies. I think a nice thing would be maybe some kind of certificate platform could offer some kind of GUI for like describing these policies and let you know what they're really doing. but I'm not sure if maybe restricting certain fields to have certain policy like these kind of wildcards and things like that, because we'd be making lots of assumptions around how it actually wants to be used. It actually might be really valid for example.com star to exist, right? Perhaps it's an organization which manages like or has lots of like example.mon subdomains for like this kind of thing. I don't know. Like, yeah, it like that needs to be a subdomain because that's the kind of how their kind of DNS looks like with their internal services, right? Like,
I guess maybe I'm thinking too much about DNS and sort of the wider internet, and this would actually apply to internal DNS, which could have anything in it.
Yeah, I mean there is another layer behind this, right? Like I'm not sure about like the example.star case being a problem, because you still need to actually do like if you get example dot some weird TLD, you still need to still needs to be issued from the issuer, and then you need to figure out what you can do with that to like to do that. I'm not really sure, but if there are standards for how wildcards work in TLS in DNS names, with the star.example.com not allowing a.b.example.com, like that feels like maybe just from a principle of least surprise, if there are rules people are used to for wildcards and DNS names in TLS context, that and using those is what people will expect that we are doing. But that's not going to apply to like if you can wildcard every field, the street address, like there's probably not a standard for that, right? So allowing normal wildcards there, but for DNS names, maybe it is right to follow the standard.
I think it sort of ties into a different thing I've been thinking of, which is for, say, the CN and the subject alt names, if you do place a requirement that it be a valid host name, what that would have from a usability perspective is that it would bring the failure point to when they try and create the policy versus when the policy is applied to a given request. That seems to me it would be a better user experience to have it fail at creating the policy, because the policy could never apply to anything, because you couldn't create a certificate request with a dash on the end or two periods in it consecutively.
So I guess this is talking about just adding because we'll do validation on the policy resources. So I guess it would be validation there, basically, that the allowed DNS names can only include proper DNS names plus wildcards, I guess.
Maybe a slightly extended version of what you could request from a Let's Encrypt wildcard. So I suppose the way I'm thinking about it is that the type, a very high level, the type of the sort of allowed CN and the allowed SANs, that's sort of a DNS name string. It's not just a string. In practice, it would be implemented like that, but they're not just strings. They do have a format to them.
Just thinking about like pattern matching in general, would you want to like have it like accept a regular expression, like perhaps like wrapped with forward slashes, like how people normally denote regular expressions? So you could have like simple patterns which are easy to use, and then as soon as someone thinks, oh, I wish it was like A or B in one in one string or something, I don't know.
I've thought about it, and I don't, because it explodes the complexity and it makes things really difficult to parse. I would like to see when someone writes a policy that it's super obvious what it's going to do straight away. I think everyone can kind of I think wildcards are quite simple, and I think that's quite obvious what it's doing. Implementing or adding kind of regex means that like regex is really difficult to read. Like I spend 10 minutes on like a online regex parser like any time I want to use regex, just because like I don't remember what the stuff does, and so I made it a conscious decision not to do that. But perhaps that's a wrong assumption.
I probably agree, because I think that the issue is then that you're becoming like you're becoming a more sophisticated, you're building into a more sophisticated policy engine, and actually maybe it is good to have that like very clear line of separation, right? This is something simple versus actually you can break free if you want to use your own, which is more sophisticated, which will give you that. So I think otherwise you can end up building in everything, right? You end up actually almost like rebuilding an OPA internally,
Yeah,
or at least the capabilities of OPA.
I guess it would make sense for there to be something like, like the example that James mentioned was like, when you have like, I don't know, foo.example.com, you want to apply different rules than when you have like wildcard.example.com, that you could have like some kind of, that you choose like the closest match, like the closest match on, I don't know, the domain field rather than the first match.
But
Or like,
we can
that, I guess.
But we can do that with two different resources, right? We can have one resource that has that DNS name and then this resource that has that DNS name. And so it's either going to pass one or pass none. The problem with if you have these kind of nots and things like that or ifs in the actual resource itself, is then it's quite difficult to kind of traverse the if statement in your head when you're reading it, if that makes sense. And it becomes a bit ambiguous.
That points at an interesting thing actually, where you could match multiple policies. So if you had a host name that matched both a start and a specific one, is there this may be in the document, I've not seen it, is there a provision that says like it will match the more specific one first? So if there's a policy for foo.example.com, it would match that rather than star.example.com.
So it will attempt every single policy which it's bound to. So it will just go through all of them. The first one that approves it, it's approved. So if you have multiple policies that all approve it, then it's no different than having one policy that approves it. If that makes sense. It's just going to try them all.
Yeah, there's in this design, there's no deny. So ordering and that and specificity and things like that don't matter, because either something approves it or nothing approves it, and it doesn't matter what order you do anything in or how specific a policy is. I think that we might have a problem. I'm not sure, but I think we might have a problem with the cert-manager controller and policies. Just trying to think it through, because if the rule is that if there's any policy, then everything must pass a policy in order to be done. Like you want to lock down something within your system, like you're using istio-csr and you want to lock down that only you lock down the namespace of istio-csr. You've now got a policy within your system, so the cert-manager controller creating certificate requests from certificates will now get everything denied. So now you go and find. Sorry.
So no, I was just saying yes.
Yes. Yeah. So now you go and now you create a policy that is allow all, and you bind it to the cert-manager controller service account, so that now anything the cert-manager controller creates is allowed to go through, so your certificates continue working. So we should put that in the docs as if you're creating a policy, create this one and apply this, as you apply your first policy in order to have your certificates renewed. However, there's then a problem if you ever want to control those certificate requests, right? Like if you want to say I don't know, I don't know, any rules you want to apply you have to go and, I don't know, is there a problem there where you can't then go and apply policy to the certificate request created by the certificate, because you have to have an allow all in there to keep everything working?
I think this is a problem all the time anyway. I'm pretty sure the kind of recommended way to implement network policy is to do deny all and then fix everything. I can't really see another way to get around it. We can come up with these ways to do these kind of dry runs or these kind of audit runs where we can, and perhaps this is something that shouldn't be in cert-manager. Perhaps this is some kind of external service or software which aids in that migration. to do that. But yeah,
I guess you can.
You can't have policy without kind of defining what the policy is going to be, right? Like, you just have to go through and write all the policy you need.
I guess you can change your baseline policy. Like if we call what you grant the cert-manager controller as like your baseline policy, just like your minimum key sizes and things like that. You can modify that so you don't have an allow all, but you have your baseline policy, which is assigned to the cert-manager controller. But that has to encompass everything, right? Like, you can't have another policy which has a more specific case or anything like that, because you just have, an allow all or just a minimum key size restriction on all of those certificate requests. So you can't have the, if you're, I think it comes back to the like, example.com has a greater minimum key size requirement case. I think a lot of it comes back to that. You just can't really do that use case. Without some sort of conditional or not or that kind of thing within the system, but
that match thing,
maybe that's acceptable. I don't know.
I think
it is something that we can. We don't have to figure that out now. Like the match idea, we can just add that. It's entirely additive on top of what's like, because.
And we can break the API, like C1 alpha 1. Like we make no guarantees that we won't delete it, right? We might completely delete all of this. So I think that's absolutely fine.
And you suggested at one point like the caret to do not, and like I think you could do that as well. But like we did talk about like this doc is presented as here's the baseline policy and here's how it's extensible. Like actually implement it the other way around, and here like implement the extensible stuff and then prototype this as an external policy server rather than passing it into core and like trying these things and trying it out, and then maybe we modify it and add these kind of things in there to make it work. I kind of like that idea.
Yeah, I think my feeling on that is that I would like something to be in core from day one, so people can try it without having to install extra stuff. You can do both, basically, is what I'm trying to say. We can have something in core which does something from day one without extra installation, and you can also try the next version, because all you need to do is put the policy as allow all plus this external server, which is the kind of next version of the kind of base policy, if that makes sense.
Yeah, I think that's a reasonable argument.
I had a question, which is different if we finish talking about that, around the policy request and the policy response messages. I wondered if you had an example of those, or just were willing to talk about a schema of the policy request in particular. I suppose I'm interested because it looks to me like stuff is pulled out of a certificate request here. Why not just send the whole resource?
Yeah, so this is to ensure that we are able to also send certificate signing requests and not have to change the API. So it means that
if you just send the whole resource, then you could send any cert-manager object in the future.
So this is the upstream CSR API. So we're talking about migrating or adopting the kind of Kubernetes CSR resource, not the certificate request resource. By not sending the entire request with the same, with the exact same schema as either resource, means that we can basically shim between them two. So both the certificate request and the certificate signing request can be converted into this message.
And rather than possibly certificate as well, I guess, in the future, right? Like you could.
Correct. Yeah.
Yeah.
Yeah, but then it does limit you. And for example, I don't know whether people would ever want to write policy over issuer resources, but some cert-manager resources don't fit into this schema.
Yeah, correct. Yeah. So maybe we should rename this message to not be policy response, but certificate request policy response, or request policy response, and request request or something. Because yeah, I agree. Perhaps we can add more policy in the future, which is concerned with other cert-manager resources, but that would be completely separate gRPC calls, separate messages.
Yeah, and we wouldn't want to define this API as just being, oh, we will send you any Kubernetes objects and you figure out what to do with it. Like I think we want a more specific API than that, that allows you to build a policy engine.
We can add as many messages as we want. And I think it's proper to separate these different objects as different messages. Yeah.
Yeah, I think like if you name them accordingly, that's fine. I mean, I saw that it was out of scope to have policy on certificates, for example, but it did seem like a natural next step at some point. And I was interested as to how that would be handled.
Yeah.
The other thing that I was going to comment on in the policy response thing was you've got the enum of the result and then a reason, but I wondered if you might also consider requiring that they provide a policy version that made that decision, or whether that was going to be logged anywhere other than just logs. Whereas that is the kind of the policy decision annotated on the resource in any way, or are we just relying on audit logging of the external policy server and the cert-manager controller, which is calling them to keep tabs on that information?
Yeah, so I think, yeah, that's a good question. Adding that kind of information to these responses is something we can do. We can probably add it as and when, like that's the nice thing about using gRPC. We can just kind of extend the API and go from there. The intention behind the reason string was that this is the thing that's going to be bubbled up onto the certificate request denied condition. So once this certificate request has gone through all its policy checks, if it ends up getting denied, then on the condition it's going to output why it was denied and where it was denied from. And similarly, if it was approved, then it's going to be, say, it was approved because of this certificate request policy, for example. So that was the intention behind the reason string. But yeah, we can certainly extend this API if it's beneficial.
Cool. I did have another question, but Miles raised his hand, so I'll let him go.
Yeah, I have two quick questions. Is it okay if the external issuers do not support the approval mechanism? Like, I guess it's not really important.
Yeah, so as mentioned earlier, as soon as 1.3 comes out, we should PR against every external issuer that we know about and add that if statement in. So it's also in the condition, when I add the condition that PR. Basically, we should take it upon ourselves to just go ahead and PR in, because it's literally an if statement. If it's not approved, then return nil, basically, is what we should do everywhere. And we should make it super explicit in our external issuer code example, and just write it in the docs in big, bold, italics, font 20. That needs to be done. And it's,
yeah, so it's kind of breaking the API. It is, actually.
How do you mean?
A little bit.
But the API includes a new behavior that you have to implement in order to abide by the cert-manager API.
Well, it
Like
means that without it, they'd bypass.
Sorry, what?
Yeah, just that without it, they'd be able to bypass policy.
Yeah, exactly. Exactly. Or actually, it's not bypassing, because if you don't approve, cert-manager won't do anything, so it's fine. It's just the problem is just that.
So the approver does.
Oh no, never mind. Yeah, sorry.
Manage the external issuers as well. Yeah. So it will do approval for those different requests as well.
I guess that we could do a thing where if the issuer supports policy, it adds an annotation or something on the certificate request, and then the certificate controller, the certificate request controller that actually goes ahead no, that's not really going to work, is it? It would work for
No,
certificate,
because you
but not
can
for
just
certificate
create a
requests.
certificate request that says, yeah, this doesn't have policy, it's fine, that kind of thing. You know.
No, I mean, like, if the it would only work for certificates, but like if the issuer supports it, it can put the annotation, and then the certificate request can go, oh, it's not approved. I don't know. Maybe there's a way to do that, but it doesn't actually help like just the pure certificate request support use case, because the spec.cert field is going to be there, is going to be filled in status.cert. So that doesn't help. But I think it's totally acceptable to make this change and do the PR to all the ones that we know about, as you say.
Yeah, and then we would just have to keep track of the list of enabled policy enabled issuers on our website until all of them are compatible. I guess.
Sorry,
yeah.
This is relevant. It might be just my sort of lack of understanding of the architecture here, but why do we have to do that? Why do we have to raise the PRs and everything? Can we not have something before the issuer is ever invoked that checks the policy and does it wholesale?
Yeah. So we could do it at admission time. The problem with that is that approval can take an undefined amount of time. One of the use cases, for example, so admission webhooks have a limit of like 2 seconds or something of timeout. I believe that's true. And not least the HTTP will time out at some point anyway. It doesn't cover use cases, for example, manual approval, which is possible using this kind of setup, which is kind of behavior that you only kind of get with doing it the kind of condition controller type way of doing things. I hope it.
Yeah, an external issuer is just a controller that watches certificate request objects and acts on them. So as soon as it's created, they will trigger an act. We need to add the if condition so that they wait for the approval. So we'd need to add some new resource type or something to make it work. But
okay.
There was one other thing I wanted to ask about the policy response, or just the policy request, policy response thing. I've seen it's quite common in applying policy to just generic Kubernetes objects with Gatekeeper and OPA to have related resources or a means of kind of evaluating policy in some wider context. Whether that be other resources of the same type and validating that some field is unique, or whether it's based on some annotation which is set on a tenant namespace, allowing them or not allowing them to do certain things. Mm-hmm. I don't see any way of sort of providing that information about the context in here. Perhaps it's not a problem, but it's quite common.
So I think since we've got all the Kate's metadata sent over, can the external policy not make that or infer that information based on the metadata? Because we'll have like self-link and all the other annotations and things like that. Can the external policy server not gather that information?
Yeah, I suppose it could. Yeah, assuming that it's running in a place that has access to that. Yeah, no, I suppose I hadn't thought about that. Just to kind of imagine that it would need to be sent in the request.
Yeah, the request, back to what Charlie said a minute ago, I think it probably wants to be a one-of, doesn't it? Like policy request is then like a one-of of like request policy, like request or something like that then allows us to be extensible without having to add multiple gRPC endpoints if we want to do different types of requests in the future.
I have to admit, I'm not super familiar with gRPC.
Okay.
Syntax, so yes.
Yeah, I think we just need one level of nesting, that we define a top level policy request message, and then the contents of that are one of like request or issuer request or certificate request or that kind of thing, and then it allows us to be extensible without having to add a new if the analogy of HTTP is to make the like payload to your one REST call extensible rather than requiring a different URL to
Yeah.
make that call.
Yeah, absolutely. Yeah. The policy request message is purposely ambiguous until
Yeah.
I
It's,
learn.
it's empty.
Yeah.
The only thing that this is not really, it's like related to all controllers around policy rather than just this one. But I'm always worried about time of check to time of use issues.
Mm-hmm.
I don't know where I'm going with this. It's just I'm always worried about it with lots of async controllers that are implementing policy.
We're making requests immutable, right? Essentially.
Correct. Yeah.
So I think that covers most of it, but there would you can't you'd have to be careful checking a duration field, right? Like the duration can't extend beyond this date, and then it actually gets issued 24 hours later, and the duration is beyond that date. You would have that kind of case, but I think making it immutable solves a lot of those issues.
In theory, signers should be doing duration based off the timestamp of the resource, not when they observed it.
Right.
Which should be the proper semantics of it.
Right. But yeah, there would be things like, you build an external policy server that goes and looks in your Active Directory or something like that. You would get a time of check, time of use vulnerability with that kind of thing. But I don't think there's any way for us to get around that kind of thing in an asynchronous system like Kubernetes, right? We can't entirely control that kind of thing without putting all of this into the issuers, and we don't want to do that.
I wanted to ask about something you already mentioned, the stand-up, that there's no pending condition. If so you said if one policy crashes and there's another one that doesn't allow it, it will just keep recycling it. Would it not be problematic? Will there be any way to specify a backoff so that the controller is just not busy constantly recycling one request because the policy has crashed? Yeah,
so the approver controller will not set the approve condition at all, and it will add a kind of resync. What's the word for it? It will add a I forgot what it's called in the code. Requeue after, or whatever it is. It'll add a requeue after to its own queue. Yeah.
So it will basically keep going. If it happens to be the case that one has crashed, it will just keep requeuing it. If it never recovers.
Not in a tight loop. We'll check it later. Perhaps have some kind of back off to it. Yeah. But yes.
On that note, is there a difference between denial and permanent failure?
Yes, there is. Yeah, the two different condition types.
Well, there's error, which will be retried, and there's denied, which won't be retried, approved, which won't be retried. But do we need a permanent error, which also won't be retried?
Yeah, I think we need to go back to the old one, because we need to have approved false because of an error, denied true, and approved true. We also have the ready condition, which defines whether if the request has failed or not, which is how that's done. Perhaps that's what denied means. Denied means that approved equals false and ready equals failed.
I'm not sure. I'm just thinking about what an external policy server might want to return. It's this isn't a policy being denied. But it failed in such a way that I can't see this ever working. That's an interesting difference between that and an error which should be retried, I think. But
do you mean
Well, that's essentially denied, right?
Yeah, but I suppose it's kind of a way of representing potential misconfiguration. It's not a kind of
Yeah, but
sort of
I
happy
mean,
path
like
denial.
we don't actually have denial in the system at the moment. Like what's called denied there isn't actually denied; it's just not approved. But what
Yeah,
you're
okay.
talking about is denied. Like I am not approving this because I don't know whether it will work, and there's no way I will ever be able to tell you that it's approved. So you can't do this kind of thing. No, I guess it's not because we just don't have denial in the system. But that's what you're.
So
Yeah,
I think
so-
one way to solve this, and it's something we will do. I haven't included the messages here, but we will have like a external policy server health message, where that will be used to define the external policy server resource condition status. And so if cert-manager, if the external policy server reports that its health is bad due to a config error or something like that, it will mark the external policy server resource has failed, and therefore the approver, when it kind of goes through the external policy server list, if the condition on the external policy server resource is in a failed state, then it's just going to automatically put it into put that policy as like not approved. That makes sense.
Yeah, okay. Yeah. But wait, so it wouldn't try if the policy, it wouldn't try that policy server if it was in a failed state.
Correct.
So what happens if you have a external policy server with multiple policies loaded, one of which is valid Rego code, for example, another which is invalid Rego code, which would result in what I'm calling a permanent error? Then that whole controller is taken out when only one of the policies is permanent error state.
So are you talking about being in the same external policy server?
Yeah, so like in an external policy, like in OPA, like a common pattern is to load in lots of different policies, and then you hit the policy server and it gives you a response. So I was imagining doing something like that, but perhaps you're expecting an external policy server per policy.
No, so I think that those semantics should be defined by the external policy server, and it will be up to them to define what these things mean to them. The external policy server needs to decide if one of my policies is bad, then do I report ready or not in my health check? That's up to them. And it's also up to them to decide what they put in the response if indeed they mark themselves as ready, if they want to return in an error, denied, or approved state.
Yeah, I suppose I'm just wondering how you find out. Like, how do you find out if you deploy one of your policies as a to your external policy server's configuration, which is broken? What's the best user experience there for somebody to find out that there's an error that they've deployed and that policy is never going to complete successfully?
I guess they'd see that the condition on the external policy server resource is bad, and yeah, the user will need to then look at the external policy server, whatever that means for them. Perhaps it means checking logs, or
yeah,
who knows.
Yeah, I suppose I'm just imagining, like, if we go and build an off-the-shelf OPA external policy server, it would be, I suppose, like, I'm expecting that users often won't have built their own external policy server. And we should think about what we can offer there in terms of something that's easy to use, in the same way that we think about that for cert-manager.
Yeah, I think maybe there needs to be an extension to the external policy server interface to account for an OPA server. Because if you are loading in 100 policies into your OPA server, you don't want to run 100 shims to reference a specific policy and do that kind of thing. So there might want to be an extension to support that better.
Why can't the shim decide which policies to run based on the input? Isn't that like the point of OPA anyway?
Well, if you I don't know, if you have an OPA instance and you have 100 policies that apply certificates, and you want to say, oh, I want this user to fall under this policy, and I want that other user to fall under that policy, like, you have to do that with certificate. With it, you need to then define, like, how do you do that other than defining external policy server for each policy, and then running a
why
shim
can't they all
for
point
each
to
of
the same
those?
why can't all point to the same external policy server?
Because they need to know which policy to apply for for that user, because the RBAC binding on the policy.
I think this gets into the realm where your external policy server needs to be a bit smarter then.
I'm not sure how it can be, because we're not passing through enough information to allow it to do that.
What's missing?
Some sort of key or something. I think that's what I'm saying, is we might need to extend it to allow it to be done. But I don't know. I don't know how you actually. I've never set up an OPA server or anything like that. But it smells to me like this wouldn't be convenient to set up.
You're saying we just add a map string to string to our external policy server that will just pass that metadata in every request.
Yeah, and then maybe pass that through from the policy document as well. So when you reference an external policy server, you can also specify some extra metadata. But I don't know. It's definitely something to look into and figure out how it would work. But it just smells like that to me. And maybe it's not needed at all.
Perhaps I've missed something, but when will an external policy server be called? What will be called?
So the approver controller will gather all external policy servers which are bound to that certificate request. So it will do a filter, and then it will call every single policy in turn. So say we have 3, it's going to go through number 1, it's going to make sure it passes the base policy, and then it's going to call every single external policy there is on that list. And then if it doesn't approve, then it'll go to the second one. If it doesn't approve, it'll go to the third one.
Okay, so the name of the server, external policy server, could be referenced in the policy object?
Yeah, that's right. Yeah, and it's the name of this Kubernetes resource of the list there.
Okay.
So to me, this seems solid. It seems like it's going to produce a working system. We'll be able to extend it in ways that we want, and be able to learn from that and make changes. So this feels like something we can go forward and start to implement. Does anyone feel differently? Does anyone have any concerns that haven't been addressed, or ideas for other approaches we should be considering?
Can I just mention again the UX considerations since we're discussing the API? So from what I understand, we have 2 different models or mode of operations. The first one with the policy API, so this custom resource, would be allowing everything by default. Is that correct?
That's correct. Yeah.
Yeah. Okay. And the second mode of operation would be to use, instead of the policy API, you could use the policy server Grpc API that would be called by cert-manager. And this is using the deny all mode. So everything is denied by default. Is that correct?
No, so it's the same thing. So in my policy resource, I define my base policy, the one you described, as well as any external policies which I might be using for this policy.
Oh, why did? Yeah, okay. My first question, I heard about a migration thing earlier in the discussion, but I didn't really understand what migration did we talk about?
So I think that was discussing that today in cert-manager we have no policy. Therefore, if we introduce policy, then the default behavior needs to be allow all, because otherwise it will be a breaking change. You can't upgrade cert-manager, then all of a sudden nothing gets signed because everything gets denied. So the migration is that by default, the policy is allow all, unless a single policy resource exists, which should signal to us that the user wants to use policy, or a second mode of operation where we can set a flag on cert-manager that regardless of whether any policy resource exists or not, it will be policy will be applied.
Okay, yeah,
And
that
if
makes
no
sense.
policy exists, then it gets denied.
My last question is, can we make sure? So, from what I understand, everything is going to be allow all by default, which means it's quite easy to check, like to let the user know why this certificate request has been denied. So I'm happy with this. Is there a section in this document that explains how we are intending the UX to look like? Like just an example with the condition, with the reason that says, okay, here is why you have been denied, or something like that. I just want to make sure that we have a plan on for this.
Yeah, that's right. I haven't added like a condition string or like what the strings are going to look like. Like I have like a rough idea, and I guess we could probably all come up with like something in our heads. I think I'd like some ideas here. What would be really clear to the user? I think like I posted that message in Slack, for example, of like what the error string looks like today, which isn't super great, but it's not bad. So yeah, something around that. I think as an end user, the key things I want to see is who denied their request or who approved the request, and if they denied it, why did they deny it? What was my input, and what was the rule that denied it? I think.
Yeah, that makes sense. That makes sense. Can we have this like these for bullet points? Just add it somewhere so that that would be awesome. Even like the condition is not really a problem. Like it would just make sense to discuss what information we want there, because it's so important. And if we miss it and we have to break the API for some reason, afterwards, because, like,
I think that's a big problem with post-security policy as well, that it's like very ambiguous what's going on.
Yeah, exactly.
I think it can get so much further by just saying this certificate request is approved because global allow all certificate policy approved it, kind of thing.
Yeah, but so I was concerned about the deny all thing, but apparently we are not going that way. Deny all is really hard to debug, but the allow all policy, so you allow everything and then you restrict things, is easier to debug, I guess.
Yeah, exactly. Yeah.
I mean, there will be a deny all mode.
Yes, as soon as you put a policy on, how would I?
Yeah, but there's not a lot we can say in that other than this request was denied because nothing approved it.
Yeah, that's the problem. It's always the problem. You cannot do anything about this, anyways.
So if you
cannot, I think it will still be better than the PSP thing when it's missing, where you've got to go and like work out what's trying to create the pod, and so on. Whereas here we'll actually have the resource saying, we'll have something clear saying it's been denied, and this is the resource that's.
Yeah,
the resource is there. Whereas in the pod security policy, the pod just never exists, and you've got to work out a bit of a detective game as to why it's not there.
I guess it would be better to say this was denied because nothing approved it. The policies that were consulted were, and list the policies that were checked, and then you can see whether you haven't bound the policy to the user or the policy didn't allow it, and that would definitely be more helpful.
Yeah, exactly. Just have a list of policy resources that have been consulted. Yeah, that's a good one.
I think it's too hard to do better than PSPs. I think,
and also like if thinking like each one can then give a reason, right? Like particularly with external servers, like these ones were consulted and they said like this was the reason given when consulting an external one, and maybe the short message from an internal one. Trying to structure all of that into a condition message. I don't know how you're going to go about doing that, but
200 lines, 200 like impossible to. Yeah, but at least the person would have something.
Yeah, I think we should be as verbose as possible, because like normal operation, when everything is ticking along, it's all the approved message is going to say is this different request was approved by foo. Whereas the edge case condition, or the condition that shouldn't happen very often, is when things go wrong. And when things go wrong, we should illustrate as much information to the user as possible.
I think,
thinking about a nice way to do that when it might be like 1,000 characters long with nested, square braces and quotes and gRPC error messages embedded within JSON strings embedded, like trying to just make it so you can see, like, I don't know if there's a way to put it in status or something like that, where you can see, map, this one, this was the message, this one, this was the message, more of like a map than just a string, serialized string.
In fairness, though, if you were implementing your own policy engine, or you're wrapping something like OPA, I mean, I guess you could have like much more verbose logging. That side, right?
Yeah.
So yeah, I mean, in fairness, you still have to go find it, but at least that way you might still have that. You might make a kind of a log, right, of the full.
But making this structured makes it easy to consume from a service such as JetStack Secure, which could then present this information rather than it being hidden in logs.
Just through the case API, and just having that visibility, right?
Yeah.
Not to fish your way to it.
And if it's structured rather than a serialized string, then we can do a great presentation of it that really helps people understand it.
I think it's easy from an OPA policy to return quite a descriptive error message saying this is what's happened and this is why it's happened. But I think the schema that you've got at the moment, where it just returns a string, is probably going to be fine. I think the structure we're talking about is on the cert-manager side. I see it. I suppose we did use a string in pre-flight for a long time and then changed from doing that because we wanted to kind of aggregate failure messages and kind of provide some like more rich information about the context. But I think like the context in the cert-manager policy evaluations is much clearer, as in like we are giving you a certificate request resource, or we are giving you some other type of resource in the future, and like it's just this resource, and it's not kind of analyzing like a big blob. I think it should be fine having just a string.
And it would be perfectly possible to add into the external policy server response message like a map string or something for extra metadata if we knew what we were going to do with that. Like it's pointless putting it in if you don't, like, if you're just like, oh, we're just gonna serialize this into a JSON thing, like, is that what we want? Is that actually helpful? But it's the kind of thing you can consider to allow something like OPA to provide more metadata than can be reasonably put into a string, if that is it's more useful if that's kept as structured metadata that is held along with that rather than just serialized into the string. Because if it's serialized into the string, the metadata server can just do that itself anyway, rather than at these extra steps to do that.
I suppose at some point we might want to have something which is like, I've just been working on alerts for JetStack Secure. All policy violations, you may want to have policy violations in the prod namespace be sent an alert, and but I think with even then, like, you've got the namespace information and things. So I guess we can cross that bridge of providing structured data from policies when we come to it. It probably will come, but we might as well do it when it's informed by an actual use case. I'm going to go get my lunch, but thanks for presenting, Josh. It was really good. All looks very interesting.
Yeah. Any major concerns, or should we like plow ahead now and update the doc and get on with the implementation?
Such a great day's life. This is, in my head, the most controversial addition to cert-manager. And one meeting I said, let's do it.
It's such a great design. That's what it is.
It was really good.
Yeah, it's easier to understand than the CSR thing. It's way easier. That's why.
That was a lot harder. Yeah, I agree.